Hi, my name's Martin Smith, and I'm going over particle waves and how they would create vacuum vortexes within ether. And I'm starting it out by going over two tsunamis, and how we have an energy created in one place, how it goes through a waveguide called the ocean, and it changes velocity due to temperature, and it changes velocity due to pressure. So the ocean has pressure differences all the way through, and it also has temperature differences in layers. So what these do is, while it's going through the waveguide, the wave's slowing down, and then it is reflecting off of a surface and then going upwards and lifting up the water. So as the water lifts up, it's siphoning water in from both sides. So also the waveguide would be hitting this side first, and it would create a wave going up like this, which would send most of the water back to the shoreline when it comes back down. So we have two types of waves here. One is a sonic wave traveling through the water, and the other one is a mechanical wave that is actually lifting water upwards. And like I say, also when it's lifting water upwards, it's drawing water from the sides when it does it. So the waveguide would actually be spreading out the waves, spreading out the compression waves, and then putting it back in. So it's not one giant bump or hit that's hitting the surface of the water. It's actually a slow pressure which takes time to lift it, and that gives it the time necessary. I noticed these waves once when I was in a kayak out on the ocean, and my little kayak got hit by a sound wave, and what it did is it just shifted the entire boat sideways by about a foot, and I had to use my paddle to brace in order to keep from flipping over. So this is looking at how fast they move, what are the mechanical aspects of it, and I'm mostly looking at if you look at dictionary terms, they're talking about molecules. Well, it can be the vibration of the atoms in molecules, or it can be through elements. So we're not talking about the wave traveling through, as in if we have water or solids, it's not the electrons and the protons that are absorbing and being the spring constant. It's actually the motion of the molecule and motion of the elements going back and forth. So as the wave's traveling forth, you're having a compression, but what's really being compressed is these little bumps. As the compression goes fast, travels this way, that means the interaction between them becomes faster. So even though we have a sonic wave moving at the speed of sound, the vibrational speed is actually moving faster than the speed of sound because it's going across this way and it's bumping back. So that is your compression in these waves. And when I go to create vortex waves, and instead of using molecules or elements, I'm just claiming they're quantum dots and using them in that form, just because we don't know what a quantum dot is. I mean, even if you look at this theory and say, okay, we use quantum dots and they're approximately, the size of them is approximately 1 × 10 to the minus 78 or 79, somewhere in that area, meters. 1 to the minus 78 meters, somewhere in that area. Still getting a mechanical idea of how they work to create vortex waves moving at the speed of light. This is the issue that we're going over today. Okay, looking at two tsunamis, they're either started by earthquakes or by landslides. So what we're having an energy, a large form of energy. It goes through a waveguide and then presses energy upwards to create an upswell and to draw in water into that upswell. So what I'm looking at on this is the actions of it is we have a sound wave coming through here. It's being sped up through density. It is also being sped up through higher temperatures. So each one of these layers, and as the density increases and the temperature layers increase, it's going to speed up or slow down these waves. So some of these waves are actually going to be coming in at an angle. Some of them are going to be going straight through, but they are compression waves. So what this thing's doing, this guide is doing, is it's changing the waves and it's making it longer. So we're hitting a 45-degree angle or less if there's bumps. If there's bumps along here, all it needs is a redirect of direction so that it's going from this direction to an upwards direction to create this lump here. The amplitude of a sound wave as it decreases with distance from its source, because the energy of the wave is spread over larger and larger areas. Well, it is spread over, but it also follows a waveguide. So we have energy being transferred through waves. So now the waves have the energy and they're being spread out. The bottom of the ocean is working as a guide, and a large portion of that energy is coming through and making it to here, transferring up. Now, at this point, we have a sound wave, and it is being transferred into a mechanical wave, and it's a mechanical wave that is doing the damage on a tsunami. Okay, this last one was a quote from YouTube University of Physics, and if you want to Google it, it's Sound Waves University Physics Volume 1. Okay, I noticed these sound waves when I was in a kayak, and it nearly flipped me over. I think that was a decent picture for a kayak. So what we're looking at from a mechanical point of view is we have molecules in motion, and in air they are quite a bit very much spread apart, but in water they're not. So if you're in water, the pressure in which that water is applied has a mathematical equation for that, even in air. So what we're doing is we're taking a molecule, and I'm using circles to represent either molecules or atoms, and as they bounce back and forth, the wave isn't just moving this way. The parts of that wave are actually moving in both directions, or three-dimensionally, not just one-dimensionally, not just two-dimensionally, but they're actually moving three-dimensionally. So the waves in motion are actually going backwards to some degree as much as they're going forwards. So the speed of the individual molecules bouncing back and forth is still faster than the wave itself, and that wave compression has a certain speed to it regardless. So I'm looking at sound waves in water going, that's what, approximately 5 times faster, just under 5 times faster in water than in air. But the temperature also makes a difference. So going to these two formulas, I'm not really too worried about what each one of these things represents. What I'm mostly looking at is this word right here, displacement of molecule, pressure change from sound wave, and that's the pressure of the molecules or pressure of the atoms. And I'm looking at it from the concept of pressure of quantum dots. So I'm trying to apply the same mechanics that sound waves are traveling through water as waves traveling through ether itself. And yet some of those mechanics through ether are going to be different than traveling through water. And I don't know that I really described this all that well, but I think that's about as good as I can do for now. I will try and do better on the next video. And I will see you later. Bye.